Hi, my name is Massimo Referre. I'm a principal technologist in the AWS container team. And in this section, we're going to talk about AWS Fargate, Amazon ECS, and Greg Sterling from Affirm is going to share with you their experience for running batch workloads using AWS technologies and open source technology for their particular use cases. So let's dive in. So this is the agenda. It's a pretty packed presentation. In the first part, I'm going to introduce at a very high level what we mean by batch workloads and what the characteristics of these batch workloads are, and some of the foundational services that we're going to talk about, namely ECS and Fargate for this session. In the second part, we're going to go a little bit deeper into some best practices, architectural patterns that we have seen our customers adopting when running batch workloads. And we're going to talk a little bit more about some new features that we introduce around AWS batch and so forth. In the last part, Greg is coming on stage, and as I said, he's going to share some lesson learned by using some of these technologies. This is a deep dive on AWS Fargate with a spin on running batch workloads on AWS. If you want to learn more about AWS Fargate as a technology, the value prop, and stuff like that, this is a list of sessions that you should not miss. As I said, if you want to learn more and dive deeper into the technology per se. We will have a few slides just to create a little bit of context and the baseline to start with, but we're not going to spend a lot of time describing what Fargate is and how Fargate works. We're going to spend more time on discussing how to run batch workloads on Amazon ECS and AWS Fargate. So what do we mean by batch workloads? This is the definition that we typically use when we define batch workloads. In a nutshell, batch workloads are, or batch jobs, if you will, are those workloads that do not interact tightly with an end user, right? So these are not transactional workloads where there is a user clicking a button and waiting for a response. These are more workloads that run in the background, right? They're not actively monitored, or the user is not waiting for an answer in place. There are lots of industries that are using this type of workload patterns. It goes through financial services, life science, digital media, telecom billing, and all of them has some use cases for which they use these technologies to accomplish a particular use case, whether it's transcoding for digital media or for computing bills overnight, for example, for the telecom industry organizations. But each of them has some sort of use case for running this type of workloads. These are some of the characteristics or what these workloads require. So usually these workloads has a very high memory to CPU ratio, and this is very important when you need to go out and grab capacity to be able to run those workloads. So the scheduler and the things that you have managing those type of jobs need to understand all of these things. As I alluded to, batch workloads or batch jobs are not triggered by an end user clicking a button and waiting for something to come back. They are usually triggered by an event that happens somewhere, or it could be a cron job, right? Run this job every night at midnight, for example. They all have characteristics and optimization in how they run these batch jobs. So the technology that allows you to do this, they all have these characteristics. So they need to be able to run parallel queues, maybe with priorities. They need to have some retry logic, for example, to be able to cope with job failures, for example. So it could get fairly sophisticated. In the remaining of the session, we will start with the very easy use cases, and we will go through the more advanced requirements and how we associate given technologies and AWS services to those advanced requirement. Obviously, this needs to be run securely and in a compliant manner. And the last part is very key, flexible scheduling for lower costs. This is very key for batch workloads and batch jobs. Because as we will see, the most advanced scheduler will be able to over-index on speed versus cost, and the batch jobs are the best way to exploit some of the capabilities of the cloud. We will talk a lot more about Fargate Spot task, but you will see how you can extract a lot of value from how the cloud works with some of these type of workloads. So this is the foundational services that we will discuss. So everything that we'll be discussing will surround the notion of running these bad jobs inside containers. So one of the ways that we run containers on AWS is through the Amazon ECS orchestrator. And AWS Fargate is the serverless component that allows you to deploy these containers without having to manage the infrastructure. So as you can see on this slide, Amazon ECS, the orchestrator, supports two modes or two launch type, if you will. One is the traditional EC2. In that case, you need to manage that capacity in the form of EC2 instance in an auto-scaling group, for example. The other option, the one that we will focus on in this session, is you don't need to bother and care about this capacity. You will just launch Amazon ECS task and we will manage that capacity for you. You will only pay for those tasks that you launch because we'll manage the infrastructure for you. So these are some of the examples or reasons, if you will, why customers love running workloads on Fargate. The first one is secure by default. Usually when you have a bunch of EC2 instances in your ECS cluster, those EC2 instances can be shared among the tasks. So you could have multiple tasks running on the same EC2 instances. If you operate in a very regulated industry or market, you may want to create this one-to-one connection between the task that you're running with the instance. That's how Fargate works. When you launch a task on Fargate, we provision under the hood a VM that you don't see, and we run that task inside that VM. That's kind of how we define serverless compute, if you will, right? Because you're not dealing with servers, you're not dealing with EC2 instances. Everything that you said is a task that you launched. Compliance. The Fargate comes with a lot of badges in terms of compliance, and check it out on the website because that's a moving target. We keep adding compliance badges to AWS Fargate and other services as well. Savings is another key point. Given that you're not managing an infrastructure, there is no way to waste that infrastructure. Typically, when you run in Amazon ECS cluster, there is a lot of infrastructure that you end up wasting because of how the scheduler works and how you want to run your workloads. With Fargate, given that you only pay for the task that you're launching, there is no spare capacity that you need to pay for. Last but not least, Amazon ECS and Fargate are also tightly integrated with other AWS services. We will talk about AWS Batch, step functions, for example, but also open source software, like, for example, Apache Airflow. And Greg has a great part in this presentation where he's going to talk about how they use Apache Airflow in conjunction with Amazon ECS and AWS Fargate. Last slide on Fargate and the mechanics of Fargate. The way that Fargate works in terms of the sizing of this task is that there are a number of SKUs and combination that you can put together in terms of CPU capacity and memory capacity. Remember when I said that batch jobs tend to have a high memory to vCPU ratio? This is where you can pick the right size of the CPU with the right size of memory for your specific workload. And this is how we combine these two dimensions into a task size. And we have over 50 of these combinations that are available for use. So let's get now more into what customers are doing, starting from the very easy pattern, like I just want to, for example, schedule a cron job that runs every night at a given time, or based on a particular event. Like, for example, there is a new file coming in on S3 that will trigger a batch job, for example. For accomplishing this integration, we use a particular AWS service called Event Bridge, which is kind of an event hub, if you will, where all the AWS services events get collected, and that is where you can create actions based on those events coming in. So the two typical use cases here are, I just want to run an ECS task on a given time, or I want to run an ECS task when something happens in another service, for example, and I made the S3 example. This is kind of easy to set up. It is, however, a little bit fragile if you think in terms of resiliency, for example. What happens if, for some reason, my task fails for whatever reasons? Maybe it just needs to rerun for completing the job that it was meant to do. This setup here is very simple, but it doesn't allow you to have that logic to retry on failure, for example. So this is when customers that have some of these more sophisticated requirements tend to decouple Event Bridge and Amazon ECS with AWS Fargate with step functions. Step functions is a service, an AWS service that allows you to decouple these two entities, the event generation from where the event is running, so that you can create a little bit more logic. For example, retry logic. So you can say, run this task at this time, and maybe have a logic inside step functions, which is kind of an orchestrator, if you will, that says, if that job failed, retry running it, maybe up to 3 times, and then report that the job has failed, for example. You can also define timeouts and add notifications. And basically, you can create a little bit of programming logic around that event, between that event and the task actually running on Fargate. This is just an example of how you would configure the step function to say, if there is a failure, for example, wait this amount of time, in this example 3 seconds, just make a maximum amount of attempts to run this job before you report this job being having failed. And the other thing that you can do is you can specify this back-off rate. Usually, and this is very important in cloud environment, usually when you want to retry an action or a job in this case, you don't do this like every 3 minutes, for example, like at 0.0, 3 minutes, 6 minutes, 9 minutes, 12 minutes, but you do this with an exponential bake-off. Like, for example, 3 minutes, 9 minutes, 30 minutes, and stuff like that. This is what the back-off rate allows you to control hangover in this case. The other thing that step functions allows you to do is to create a little bit more logic to say, I want to run parallel jobs, right? So imagine that you have an array of things that you need to do. Step function is able to say, I want to run this task 10 times, for example, in parallel, and it will spin up 10 Fargate tasks to run that. You can control and govern the concurrency of these with some parameters, as you can see on this slide. But this is some logic that you can create that you wouldn't have, for example, when you have Affirm Bridge directly talking to AWS Fargate through Amazon ECS. This is not very difficult to set up, right? Setting up the rules on Affirm Bridge and creating this step function. However, it's still kind of a lot of heavy lifting that the customer needs to do when they only need to run a task with some particular logic. So what we have done is that we have introduced in AWS Copilot, which is a CLI that allows customer to program Amazon ECS using higher level construct and embedded pattern into the CLI itself. So we introduce in AWS Copilot a new pattern that allows the customer to say, I want to run a batch job using this cron job pattern, for example. What Copilot does in that case is it goes out, it will configure Affirm Bridge, it will configure step function to do what we have just discussed, creating a little bit more logic around retries and bake-off, exponential bake-off and stuff like that. Everything that we have talked about so far is for addressing kind of very basic use cases in terms of we address some of these challenges for scheduling jobs. These bad jobs, tend to become very complex very quickly, right? So you may start with a very easy logic, but then the logic may become more complex. This is where AWS Batch comes in. So instead of using Affirm Bridge and step function to create that programming logic to schedule your batch jobs, AWS Batch take over a lot of that complexity and a lot of that flexibility, if you will, and it allows you to create even more sophisticated logic, and it allows you to scale even more. Don't forget that some of these AWS services have limits in the number of tasks that you can deploy at any given point in time in terms of throughput, tasks per second, and stuff like that. And AWS Batch is that logic that allows you to create logic at the input level and logic at the output level on how you actually provision the infrastructure to support that input logic. What do I mean by input logic? It's the ability to create different scenarios for and different priorities, for example, for your batch jobs. So imagine having two different queues in AWS Batch, each of one having a different priority. And each of those queues can use a compute environment which represent capacity that AWS Batch can manage that has a different cost profile. So for example, in this example, you can say Q1 has a priority 5 and it needs to use compute environment number 1 first and number 2 as a plan B, and the reverse for the Q2. So imagine AWS Batch as that sophisticated service that allows you with a number of knobs to tune your batch jobs for speed or for cost or for any other type of dimension that you need to. So we talk a lot about Spot and the notion of Spot. Fargate Spot is a way to provision Fargate capacity or Fargate task, if you will, with a particular contract or virtual contract with AWS, in that we provision those tasks with a very high discount, up to 70% of the traditional on-demand pricing. But with this virtual contract says that if we need that capacity back, because we need to give that capacity to other customers that are using the more expensive on-demand model, we will tell you 2 minutes upfront that we will reclaim that capacity. Now, this may not work for all workloads, but this is perfect for batch workloads because, as we said, there isn't a user that is waiting for an answer, right? Usually, the response time is not a variable in these AWS batch jobs, and some of these batch jobs need to over-index on lowering the cost. And this is the right way to do this with Fargate Spot because it allows you to tell, for example, AWS batch, don't over-index on speed. I can wait. I can wait a few hours. I can maybe in some cases even wait a few days for you to wait for spot capacity to become available. And when it becomes available, just run these jobs for me. I have already touched a little bit on some of these considerations that you need to take into account. Like, for example, the AWS limits. There are limits that you need to deal with in terms of how much throughput you could get for starting tasks on Fargate. Okay, so if you use AWS Batch is aware of these and can control these things. So you need to just take some of these considerations into account. There are a few others, like in terms of, for example, scale. I was alluding to the fact that when there is a requirement for more complex logic, you would need to move to AWS Batch. Scale is another reason for moving to AWS Batch. Step Functions has a concurrency limits of 40, as you can see on this slide. So if your workloads are very sophisticated and very big in terms of scale, that may not be enough. Just to wrap up this part of the session before leaving the stage to Greg, these are some of the feature launches that we made available in 2020 for ECS Fargate. We have increased the flexibility for storage. We add support for EFS. We increased the task storage to 20 gigabyte ephemeral storage. We increase by default all of the tasks that you're running. From a networking perspective, we just enabled the dual stack IPv4 and IPv6, and there are lots of other advancements that we have done in terms of observability, where we increased the concurrency of our task. We moved from 100 to 500 per region per account, and many other things that we're doing to improve the service. Looking ahead in terms of what customers are asking us to do more, definitely we're looking at the compute space in Fargate to add GPU support, ARM processor support, as well as bigger task size. Storage, for example, we're looking at adding support for EBS in addition to EFS that we have done at the beginning of the year, and also some other usability experience. For example, being able to exec into the container on Fargate, which is not available today. With this being said, I would like to give the stage to Greg that is going to talk more about their experience running batch jobs on AWS using Apache Airflow on Amazon ECS as well as Fargate. Greg, over to you.
Hi, my name is Greg Starren. I am a senior software engineer at Affirm. And today I'm going to talk about how we do batch jobs with Apache Airflow and Amazon ECS on Fargate at Affirm. So first, a little bit of context about what we do as a company. Our mission is to make honest financial products that improve lives. And the way that we do that is we partner with thousands of online merchants at the point of sale. And when you go to checkout with Affirm, instead of your credit card, we will make a real-time underwriting decision. And we'll let you pay back your loan over time. It could be 6 months, it can be 12 months. So, we're no fine print, and we're just trying to give customers a really great credit experience online. So as it pertains to batch jobs, we run hundreds of batch jobs every single day. So these 100 batch jobs, and some of them run multiple times a day, hourly, every 5 minutes. So we're talking about thousands of daily task executions. And these pipelines are very, very important. They're mission critical. They do a lot of important financial work, a lot of important reporting, and a lot of them want to complete very, very quickly. And so they're also very highly parallelized. And obviously, because these are mission critical, availability and reliability is important. And finally, we want dynamic capacity. Because of the nature of batch jobs, they're often very bursty, right? So you'll have a lot of time when nothing is happening, and then all of a sudden you need a whole bunch of capacity. So being able to acquire dynamic capacity is going to save us money. It's also operationally a lot easier to manage. We don't have to constantly think about all these nodes and maintain them. We just kind of get dynamic capacity when we need them. So what do we want in a job framework? Well, in a nutshell, I think if you take any batch execution framework out there, it's going to have these four components, right? You need some way to define your job. You need some way to tell it when to run, scheduling, and then something needs to execute it. And then once it runs, you need to be able to see what happened. How's it going? What's the status? Notifications on results, and so on and so forth. So originally what we used was a cron tab, right? So cron tab gives you a job definition and a scheduling. The definition is the shell script to run. The scheduling is the cron tab syntax of the schedule. The execution is cron, which will run it, the cron daemon. And then notification monitoring, well, you don't really get much, but you can wrap your scripts in some notification monitoring. Now, as the number of our nodes grew, this became incredibly cumbersome to manage and maintain, right? We were deploying different cron tabs on different nodes so that we had various different kinds of job isolation. And users don't really have visibility in what's running on the cron tab unless you give them SSH to the nodes. There's no neat operational UI of any kind. There's no visibility of any kind. You have to build all that yourself. So what we ended up doing is taking Airflow. And Airflow gives us the job definition with Airflow DAGs, a component called the Airflow Scheduler, which gives you a cron-like syntax that you can define your jobs with. And it gives us monitoring and notification. There's failure notifications, there's SLA monitoring, there's runtime metrics. But for the execution, because we wanted this dynamic execution engine, we ended up putting Amazon ECS with Fargate in there. And that gave us a lot of really nice benefits. And some of the ones we were really looking for here was this dynamic nature. We wanted auto scaling. We wanted to be able to pay for what we use, spin up capacity on the fly. We also wanted jobs to reserve their CPU and memory. So, one job doesn't collide with another job. We wanted to limit the scope because what we had before is one big job might start running and eat up all the memory, and then other jobs it was containerized. We were already running Docker images as our main artifact, so this was really nice. And finally, there's no management of the underlying infrastructure, right? So we don't have to manage instances. Provisioning and deprovisioning just works out of the box. So really, you can bake your own auto scaling with Airflow and the Celery workers. But what we found in ECS, and specifically ECS on Fargate, is that we don't have to manage this. We don't have to think about security patching of these instances or security patching of our AMIs even. We just get the dynamic capacity when we need it, and we pay for what we use. And this was a little rubric that we used, some of the options that we were evaluating. A lot of people ask, why didn't you choose Kubernetes? Our main reason in this case for going with ECS is that Kubernetes is a very big thing. It has a lot of features. It can do load balancing, can do service discovery, so on and so forth. But you have to maintain that. You have to manage it. You have to build security into it, and so on and so forth. And with ECS on Fargate, we really just got exactly what we needed, a really simple API to use, and security out of the box. Now, why did we choose Airflow, right? So you've got scheduling, and ECS is great for that. But we also, our framework is very heavily invested in Airflow. And so why Airflow? Well, we get job scheduling, definition, and monitoring and notification all in one framework. It's got a very active community, and it's written with open source tooling we already use in our stack. So we use Celery, we use Flask, we use SQL Alchemy in Python. And so picking up Airflow is something that's very familiar to us. And so that was really great. And it's highly extensible. So if developers want features that are specific to their usages, we can support that. And it's also got a really nice UI for operational tasks, canceling DAGs, running DAGs, pausing DAGs, and a really good role-based access control system so that people only have access to the jobs they own. So this is the design, and most of this design is essentially just Airflow's design, right? Airflow is a scheduler. It dispatches work via celery queue. You've got a bunch of workers that are running. Depending on the status of the work, it'll notify you based on how you configure things. And what we do is we just run an operator, which is an Airflow term for the actual work being done, that calls run task with the definition into Fargate. And so our workers become really lightweight and undifferentiated. They're really just watchdogs. And all the heavy lifting of acquiring capacity, attaching the ENI, spinning up the image, running, that's all done by Fargate. We just get the capacity when we need it and pay for what we use. So with Fargate and ECS, you need to register task definitions. So we just do this on deploy. We use SaltStack, but this is just showing that when you're deploying a new version, a new image tag, you can just go ahead and register your task definition. And then here's what developers use, right? If I need an entry point, I need to run some job, or I have a bunch of entry points of constructing the pipeline, you're just writing an Airflow DAG, and you're using this thing we wrote called the Affirm ECS operator, and you're passing in the arguments. And we're going to go ahead and run those arguments, and that's going to run in Fargate, and that's where we get that Fargate run. So as a result of all of this, what we really like out of all this is there's less capacity we have to manage ourselves, and therefore there's far less operational complexity. And it saves us on cost because, unlike keeping nodes around, we only pay for what we use and nothing else. Security, I already mentioned before. We just don't have to work on patching. We don't have to think about this. We know that the environment is secure with Fargate. And it's also, Airflow gives you some security in that, compared to a cron tab, you don't have to give people SSH to nodes just to be able to do operational work on their tasks. This is something that people can do via the UI. And the UI is also really great for operational tasks for developers, like I mentioned, canceling tasks, pausing tasks, triggering a task if it failed and exhausted its retries. So it really allows everything to be a lot more self-service. Some gotchas that we encountered with this approach, the main one is Fargate limits. Fargate will limit the amount of CPUs you get per container to 4 CPUs, memory to 30 gigabytes, and disk, I believe, now to 20 gigabytes. So for most things, that's going to be enough. You can obviously parallelize for CPU constraint, but there are some jobs we have that need a single container with a lot of memory or a lot of CPU or a lot of disk usage. And so for those, we can't really use Fargate. We will maintain a small fleet of EC2 nodes, so we run ECS still, and ECS provides us that nice little interface. We'll run EC2, ECS agents to handle those tasks. Concurrent task limits is the one thing you really have to worry about when you're scaling. Just keep an eye on that. We set up alerts on it with CloudWatch. The other thing is that the ECS task history doesn't stay around for too long, so we keep a log of that via Airflow. Airflow helps us with that, and so we still retain a history of our task runs. We can't really rely on ECS for that because it'll kind of prune the task history periodically. So overall, we're really happy with our experience with ECS and Fargate, and thank you guys for listening. And now back to you, Massimo.
Thank you, Greg. That was a very interesting presentation on your experience at Affirm. If you want to know more about what Greg and his team are working on and has been working on in the past few months and years, they published a blog post on the AWS container blog that you can see in this link here. So I do suggest that you go and read it as well. With this being said, thank you very much for sticking around, and hopefully you found this useful and inspirational for the challenges that you have in your organization. Feel free to reach out if you have any question, and don't forget to fill out the survey because we want to hear from you if these sessions has been valuable to you because we value your time. Thank you very much.